Hello, today we will discuss part 2 of a two-part series in solving inequalities. In part 1, we talked about what an inequality is and how to solve inequalities. Today, we will be looking at solving inequalities containing absolute values. Similar to part 1, we will talk about what an absolute value means in terms of inequalities, how they look on a number line, and then we will solve a few inequality equations containing absolute values. An absolute value essentially states what the magnitude of a number is, regardless of its sign. An absolute value is denoted with bars around the term. And an easier way to think about this is how far a value is from 0. For example, if you have the absolute value of 3, that is going to be equal to 3. And we know this because if we look at a number line, and we have 0, 1, 2, 3, we know that 3 is 3 units away from 0, which means it has a magnitude of 3. Similarly, if we take the absolute value of negative 3, then we're still going to get 3. And the reason why is because we are still 3 units away from 0. We realize regardless of the sign, the value is still going to be 3 because we're looking at its magnitude or the distance away from 0. When looking at absolute values with inequalities, we can obtain two distinct properties. If we have the absolute value of A, which is less than B, this is going to be equal to negative B, which is less than A, which is less than B. We can see this when looking at the number line. We have 3 units in the negative direction, and we also have 3 units in the positive direction. And that is why the absolute value of A needs to take into account both the negative and positive direction. Again, we're looking at magnitude, not the sign. Similarly, if you have the absolute value of A, which is greater than B, this is going to be equal to A, which is less than negative B, or it would give us A, which is greater than B. And again, we're taking into account both the positive and negative direction. If we put this on a number line, for the first one, we would get the absolute value of A, which is less than 3. And on the second one, we would get the absolute value of A, which is greater than B. Looking at this, we have, following our rules, negative 3 on a number line, 0, and we have 3. And we're saying that the number of A is anywhere between negative 3 and a positive 3. And so these are all numbers that this could be. Looking at the second example on our number line, if we have negative 3, 3, 0, we see that A is less than negative B, so that's any value that's out in this direction. And we also see that A is greater than B, so that's any value in this direction. If we wanted to write this notation form, we would just say negative 3, comma 3, and this is saying that they're all numbers not equal to negative 3 between 3. So this just states that this is up to and this is up to. If we had greater than or equal to, then this would become a bar. Similarly, if we take the second example and use a notation, then we would have negative infinity to negative 3, And we need to use this symbol union, and then that would be from 3 to positive infinity. Now that we understand these properties, let's look at a couple of examples. Okay, looking at our first example, we have the absolute value of 2x plus 3, which is greater than 9. We always have to remind ourselves to take into account both the positive and negative values, because we are working with a magnitude or the distance away from 0 and not positive and negative numbers. What I like to do to remember that I'm working with both the negative and positive values, and we discussed this in part 1, but when working with negatives, you have to flip the sign. So often, when writing the two distinct equations of the negative and the positive, it helps me remember to flip the sign. And this goes back to the second rule that we just discussed. Looking at this problem, we have to take into account, again, both the negative and positive values. And so with that, we're going to get 2x plus 3, which is greater than 9, which is what we have. And we have to take into account the negative, so we get 2x plus 3, which is less than negative 9. Again, when dealing with negatives, you have to remember to flip the sign. And then all we do is solve this problem. We get 2x, we move the 3 to the other side, which is greater than 6. We get x dividing both sides by 2, which is greater than 3. On this right equation, 2x plus 3, which is less than negative 9, we move the 3 over, we get 2x, which is less than negative 12. We solve for x by dividing both sides by 2. X is less than negative 6. And these are our answers. If we look at a number line, we will see negative 6, negative 3, 0, 3, 6. On a number line, we see that x is greater than 3, and we see that x is less than negative 6. If we wanted to write this in notation form, we would say negative infinity, negative 6. Again, it's an open circle because it's not actually equal to that number. This is in union with 3 to a positive infinity. If we wanted to check our answer, we would have to say any value that is less than negative 6. So let's try negative 10. If we try negative 10 into here, we get 2 times negative 10 plus 3. If this is the absolute value, then we get negative 20 plus 3, which gives us negative 17. The absolute value of negative 17 is equal to 17 because there's 17 units away from 0, and this is greater than 9, and that checks out. Similarly, we need to find a value that's greater than 3. If we choose, let's say 6, then we get 2 times 6 plus 3, and we take the absolute value. 2 times 6 is 12, plus 3 is 15, which is greater than 9, and this actually checks out as well, and that means that this is our correct answer. Don't forget that you need to account for both the positive and the negative direction. Let's look at one more example. Okay, looking at one more example, we have the absolute value of 16 minus 3x, which is greater than or equal to 5. Okay, looking at another example, we have the absolute value of 16 minus 3x, which is greater than or equal to 5. Again, we have to always remind ourselves to take into account both the positive and negative values. And when taking into account the negative values, we need to make sure we flip the sign. If that's the case, we have 16 minus 3x, which is greater than or equal to 5. And we also have 16 minus 3x, which is less than or equal to a negative 5. Recall, we have to take into account the negative and the positives because we're looking at the magnitude or the distance away from 0 and not necessarily which side of the number line that this falls on. When solving these equations, we have to move the 16 to one side, so we get negative 3x, which is less than or equal to negative 11. And then we need to divide by a negative. When we divide by a negative, we need to flip the sign, so we get x, which is less than or equal to, and then a negative divided by a negative gives us a positive, which gives us 11 over 3, and this can simplify down to 3 2/3. Looking at our next inequality, we have 16 minus 3x, which is less than or equal to negative 5. Again, we move the 16 over to one side. We get negative 3x, which is less than or equal to a negative 21. We're going to divide by negative 3 to get the x by itself. We need to flip that inequality sign because we are dividing by that negative. A negative divided by a negative gives us a positive. 21 divided by 3 is 7. And these are our two answers. X is less than or equal to 3 and 3 over 2, and x is greater than or equal to 7. If we look at this on a number line, we would get 3 2/3 and 7. And so x is less than or equal to 3 2/3. Less than or equal to would be a closed circle, or you would have a bracket. Either or works. And then everything that's less than or equal to. Similarly, we have x is greater than or equal to 7. So again, you could choose to use a bracket, or you could do a circle. And we want every value that is greater than 7. If we write this in notation form, we would have negative infinity to 3 2/3, and because we are actually equal to, we use a bracket. We have a union, then we have 7, and we're actually equal to 7, and we're going out to infinity, and so this is how you would solve inequalities that contain absolute values. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.